Day 566 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1930, unique length 3 palindromic subsequences. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. Given the string S, return the number of unique palindromes of length 3 that are subsequences of S. Note that even there are multiple ways to obtain the same subsequence, it is still only counted once. A palindrome is a string that reads the same forwards and backwards. A subsequence of a string is a new string generated from the original string with some characters can be none deleted without changing the relative order of the remaining characters. For example, ACE is a subsequence of ABCDE. All right, y'all, so that sounds pretty simple, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input S equals the string A, B, C, A. The output is 3. The explanation says the 3 palindromic subsequences of length 3 are ABA, which is a subsequence of AABCA, AAA, which is also a subsequence, and ACA, which is also a subsequence. So let's go through this one step further, right? So we want to find the number of subsequences that are palindromes that we can create, right? Or the number of unique palindromes of length 3 that are subsequences of S. So in this case, we have S, and when it says right here, some characters can be none deleted without changing, or excuse me, generated from the original string with some characters can be none deleted without changing the relative order of the remaining characters. So that's how we find a subsequence. So when we do ABA, we could have this A, this B, and this A, right? So just imagine we deleted this A and this C, and then we would be left with ABA, and that's a palindrome, which is a subsequence of AABCA. Now, this is not one of those problems where we can use this A and then this A and still have a ABA subsequence, right? It says right here that if there are multiple ways to obtain the same subsequence, it is only counted once. So even though we could use this A and then do BA and then use, and then use this A and then do BA, that still only be counted once because it has the same characters. Now, for the next substring, we could do these two A's and this A, which is a palindrome of length 3. And then we could also do one of this A, this C, and this A right here, like they did down here, and this is also a palindrome of this. So in total, there were 3, so that's why we returned 3. So just in case that didn't make sense, let's take a look at example 2. In example 2, we have our input S equals the string ADC. The output is 0. Explanation says there are no palindromic subsequences of length 3 in ADC. So since ADC is already length 3 and it's not a palindrome, we're not going to be able to create a palindrome out of it. So we'll just return 0. Then last but certainly not least, in example 3, we have our input S equals a string BBCBABA. The output is 4. The explanation says the palindromic subsequences of length 3 are BBB, BCB, BAB, and ABA. So let's break this down one step further, right? So we could take these two B's right here and this B, that's going to be length 3, that's BBB, and so that counts as one subsequence. Then we could take this B, this C, and this B right here, that's a subsequence, just like that. Boom. Or, well, the example said this B, but it doesn't matter which B, like I said, they both count the same. The subsequence BCB counts the same no matter how you create it. Boom. Then we could take this B, this A, and this B right here, boom, create BAB, and then that's another subsequence of this. And then finally we could take this subsequence right here, ABA, that has a length of 3, and we could add that to our count as well. And in total, we have a total of 4 different subsequences we can create. Now, with that being said, y'all, now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we're going to do is we're going to create a string of all lowercase letters. We'll check as possible outer characters for our subsequence. So we're going to declare a variable called alph and say colon, that's going to be a string, and we're going to set that equal to a string of the alphabet. So we're going to say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z, y'all. Boom, just like that. Then we're going to come underneath this and create another counter, and this will store the total number of unique palindromic subsequences. So we're going to declare a variable called count and set that equal to 0. Then we're going to convert the input string into an array for faster index access. So we're going to declare a variable called R, set that equal to an array, open up the parentheses, and pass in S. Boom. Now for each possible character as the first and last of the palindrome, we're going to loop through it by saying for char in alph. Boom. We're going to open up the brackets. Then we're going to find the first and last occurrences of this character in the string. So we're going to say if I equals R dot first index, open up the parentheses of colon char, comma, oh, this should be if let, sorry y'all, so it should be if let I, and then this we're going to say let J equal R dot last index, open up the parentheses of colon, then we're going to say char, boom, come outside of those parentheses, and we're going to say comma, come underneath that, and we're going to say, and we're only going to proceed if there's room for at least one character, if there's at least room for one character between them. So we're going to say I plus 2 is less than or equal to J. Then we're going to open up the brackets. And the middle character can be anything in between I and J, so we'll use a set to count unique middle characters. So we're going to say count plus equals set, open up the parentheses, R, square bracket I, plus 1, dot, dot, less than J. Come outside of that, and we'll say dot count. Boom. Then we're going to return the number of distinct palindrome subsequences of form of this form that it gave us of length 3 by coming right here, and we could just say return count, y'all. Boom, that's all she wrote. Let's give it a run. Make sure it runs correctly before we submit it. Let's go ahead and submit it. It's accepted. Let's see what happens after we submit it. And look at that, y'all. 545 milliseconds beats 100% of users. That's what I'm talking about. That's what I'd like to see, y'all. So, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.